another video. So this time we have a Java problem which we have to solve. So it says sorted squares. So this is the input. So when you say the input, it also contains of, negative numbers along with some positive numbers, and the expected output here should be something like this, guys. So we should square each of the object, right? For seems very straightforward, right? But the trick here is we don't want the array in this particular order. We want the resultant array to be in sorted order, right? If the input array does not have any non-negative numbers, right, then it would be a straightforward thing. You can just square them, right? Now if you have some negative numbers also, then and this is a input is a sorted array, guys. Okay, so when the input array is sorted and it also has negative numbers, then it becomes quite tricky to handle, because if you see in this case we have squared the numbers, right, but it is not in a sorted order. Now that is the problem. So what is the expected output then? So we should have something like this. We should have, this is the expectation, guys. So output should look something like this, right? So because we have negative numbers, and we need to take care of that also. If you have only positive numbers, you simply just square the number and store them in an array, then it will do the job for you. But if you have negative numbers, then you have to make sure that everything is sorted, guys, right? Fine. Now the one condition here is the input array also has to be sorted, otherwise it won't work, right? So but it might contain some negative numbers, and you have to square each of the value that is there in the array and then return that particular array, and the resultant array also has to be sorted. Now so let's see how to solve this. So this is your template code what we use for giving the input. Now this is where we have to write the solution, guys. So now I have taken one method, sort method, basically, right? Basically this is not even a sort method, basically it is squared sort, let's say. Now let's say if you are getting this array in the argument, right? So this is what you are getting in the argument, guys. Now as I said, you need a way to store the resultant in another array. So let's create another array called result equal to new int, right? So what would be the size of this array? That would be the same size as input array, guys. Okay, now this, how do you solve this problem? So very simple, guys. This is also, we have to apply something called two pointer approach, where we create left variable is equal to 0 and right variable equal to nums dot. This will be the length of the input array, guys. Now because we have a resultant array, we need a way to find out we need to also track the resultant array. So that is why we will initialize one pointer called k, guys. Okay, now let's write the logic. So as in any typical two pointer approach, right? So we'll take the condition like while left is less than right. Okay, so now you have to do some operations, right? What operations we have to do? First thing what we have to do is we have to calculate the square of it, guys, right? And you already know that the input array is already sorted, right? So that is the information that you have. Input array is already sorted, and you just have to calculate the square of each of the number, each of the value that are stored in the array, guys. So okay, so let's say left square, something like that. Left square equal to, what you have to do, we have to say nums of left into nums of left. So I just calculated the square of the value that is present, guys, at the index of left, right? Similarly I have to calculate what is there at the, I have to calculate the square of the number that is there at the right side of the array, guys. Okay, so this is what we have done until now, right? We just calculated the sums. Now what we have found out, we did the sum. Let us say for this example, what we have found out, minus 10 into minus 10, which is 100, and we have done 8 into 8, right? So that is what we have performed. Now what we have to do, we found this is 100, square of this number is 100, and the square of this number is 64, right? Now 64 and 100, right? So where to keep this particular decision has to be made using an if-else block, guys. For example, here in this case, 65 is a bigger number or 100 is a bigger number? 100 is a bigger number. That means it has to go on the rightmost end of the array, right, at this point of time. Now that is what we have to write. Now before jumping into the conclusion, let's see what is happening, how it is happening, guys. Okay, so let's say for the very first iteration, what we are seeing, we are getting left, right, and k, right? So left obviously will be starting with 0, and right will be starting with the rightmost element, and k also will be starting with rightmost element. The reason why we are starting k with the rightmost element is because we want to store the highest element, the squared element, on the rightmost position of the array, right, at the end of the array basically, right? So that is what so for that reason we have started at the end of the array, guys. That is the reason why k is like that. Now if you see the while condition, this is a traditional while loop where we'll keep on incrementing and decrementing the left and right pointers. If you see, this is a two-pointer approach because we have used left and right pointers, and then we're calculating sum of first element of the array and the last element of the array, right? And that is how the replacement is happening using this particular logic. Every time you do a replacement, if it is based on left square, we have to increment the left position because this particular value is calculated and already it is placed in the resultant. If let's say left square is less, then we have to replace it with the right square, right? So that is what we have done over here, guys. Now I'll quickly go through my iteration by iteration for this particular example array over here, right? So very first iteration, what will be the output, guys? So let's say minus 10 comma minus 7. Let me copy paste from over here. So this is the array that I have. Now let's see what happens after the first iteration, guys. So we'll come over here, we'll calculate it as 100, right? This will be what, 64, right? Because minus 10 into minus 10, this is 100, right? This is 8 into 8, 64. Now it will come here. What will happen over here is 100 greater than 64. Yes, condition turns out to be true, and the result of what is the index value? 0, 1, 2, 3, 4, 5, guys. So resultant 5, what will be stored? We are storing it as 100, and we are decrementing the value of k by 1, right? So after this operation, k will be 4. Okay, and left, what will be the left? Left will be incremented by 1. At the end of it, it will be 1. Now we'll go to the next iteration. Next iteration will start with minus 7 because we are incrementing here the left by 1 position, right? So we'll start at minus 7, right? So we'll be coming to this particular while loop. Left is still less than right, right? Now this time what will we get? We'll get 49. We'll get 49, right? Now what is the right square? Right square still remains the same, it is 64. Now this condition will say 49 is greater than 64. No, it is false, right? So now we will come to the else block, guys. Now what will happen in the else block? Result of k minus minus. Now k is already, we have already minused it by 1 position here, right, in the previous iteration. Now k will be at the 4th position, which is this particular position. Now at the end of this particular thing, what will be there? So you will have everything will be 0 in the, because this is a resultant array, right? So we have 6 positions, so 4 positions will be something like this, and k will be at 4. At 4th positions we'll be placing this right square, guys. The right square, what is the right square? It is 64 comma 100. I'm sorry, yeah, so it will be 64 comma 100, right? This is after second iteration, guys, and we are also decrementing the k by 1 position. K will be 3. Now let's go 49. 49 is greater than 9. Yes, it is greater than 9. So we'll store the resultant at this place, guys. So I think this particular logic, right? So we'll copy and paste over here. Yeah, so 49 is greater than 9 in the next logic. Similarly, so 49 will be placed here and k will be decremented again. Alright, so yeah, this logic will continue for all the other three elements as well, guys. So that is how we are actually calculating for each iteration whether to place which element, whether to place a left square or a right square. If you place a left square, we are incrementing by the left and decrementing the k in either case, and if it is placing the right square, then we are decrementing the right pointer. So very simple, guys. If you do not understand, try to rewatch it. So basically you need 3 pointers, one which will keep hold of left and right pointers of the array, which will be 2 ends of the array, then will keep coming closer after each and every iteration depending upon which is higher, left square or right square, right? And this pointer k will be pointing to the resultant array, right? That is why in both the cases it is decrementing by one position. The reason why we are starting at the end is because we want to store the highest element in the rightmost position of the array, guys. Yeah, so I've only explained 3 iterations. You can obviously continue with this process for the other 3 elements in the array. Then you'll arrive at a complete sorted array, something like 0, 4, 9, 49, 64 and 100, which is what you see in the output, guys. Yeah, so that's all for today, guys. Thank you.